Hey everyone, welcome back to Tar Club. I'm Prahlad. I'll be explaining this next topic to all of you. So what are we talking about today? One of my favorite topics that happens to do with my field of interest, which is astrophysics. But not really astrophysics, we're just going to be mostly talking about the universe, stars, and planets. Okay? So, let me ask you a question. Do any of you know how the universe was formed? Think about it for a few moments. If you know, then very good. The most explosive tale in the universe, the Big Bang. Imagine this, our universe, all that we see, started as a tiny, tiny dot, smaller than a speck of dust, smaller than a single atom. A dot so minuscule you need a microscope to even imagine it. Then, boom! In an instant, that tiny dot exploded and expanded at an incredible speed. With just 1 second, it was millions of miles wide. That's faster than you can blink. This colossal expansion is what scientists call the Big Bang. From that moment on, the universe began to grow and evolve, eventually forming stars and galaxies, everything that we see today. So next time you look up in the night sky, remember, it all started with a tiny dot and one gigantic bang. So what existed when the Big Bang first took place? Mainly, all that was there were a bunch of, I'll not say exactly when the Big Bang took place because that goes into more quantum physics stuff. I'll just say later, a few 100 million years after the Big Bang, when nothing too interesting was happening, you just had a bunch of hydrogen atoms. Alright? Of course, you also had photons, which are the primary wavelength of light, right? But for our case, let's just say that was made up of hydrogen atoms. They're just hydrogen atoms floating about everywhere, the vast emptiness of space, until something very interesting happened. A bunch of these hydrogen atoms like this, right? They were all swirling about randomly until they all started to come together. Now, why is that? Why would they come together, you may ask? Why did they? Well, that is because of gravity, right? Gravity. Gravity is basically the force that an object exerts on another object. That's how we're standing on the earth, because the earth is exerting such a large gravitational pull on us. In fact, this pen and the cap of this pen also have gravity. It's just that their gravitational pull is so weak that we can't even see it. Right? The larger the body, the more massive the body, the larger gravitational pull it has. So let's talk about gravity for a second. The universe's way of keeping things together. Imagine the universe is a giant stretchy cloth. Now if you drop a ball onto that cloth, it makes a dent, right? That's what happens with space-time. When a planet or star plops itself down, it bends this cosmic fabric. The bigger the object, the deeper the dent. So when other small object rolls by, it falls into the dent. That's gravity in action. Think about those coin funnels in stores. Drop a coin and it spirals down slowly. That's how planets orbit stars and moons orbit planets. The gravity pulls them in, but their speed keeps them spinning around. So next time you look up at the night sky, remember, it's all thanks to gravity that everything's not floating away into chaos. So let's get on with this, right? So what happened? These hydrogen atoms, there are so many atoms that in the center they like sagged space-time a bit, and so then they began to collapse in on their own gravity. They were attracting each other because there was so much of them. Okay? And they collapsed together to form a star. Beautiful star like our sun. And it began to shine. Okay? So why do stars shine? What happens in a star that lets it live? Right? Well, that is called nuclear fusion. The atom bomb and things like that are nuclear fission, which means breaking atoms apart. Nuclear fusion is slamming them together. So you might recall that it started with a bunch of hydrogen atoms, right? Hydrogen atoms have a proton and are surrounded by an electron. Let's say you take another hydrogen atom and then you smash these two together. What's going to happen? You're going to be left with 2 protons and 2 electrons, right? And now you formed a new element, which is helium. So you take 2 hydrogens and smash them together, you form helium, and there's a bunch of extra energy that's released. And so this energy is what travels out as photons and stuff like that to let the stars shine. And that is, this energy is also what keeps the stars alive. What do I mean by that? I said that the hydrogen atoms collapse in on themselves to the gravity, right? Why did they stop here? They can keep on going until they get infinitesimally small, right? Well, it's the energy produced in the core of all stars that counteracts this force of gravitation. So let's say gravity is pushing in on the star and this energy is what is pushing out. And that is how stars are stable in their certain size. However, after millions and billions of years, right, hydrogen will form helium, helium will form lithium, lithium will form and so on, until you finally get to iron, which is Fe. Think about iron is, it's so large, right? It has so many protons and electrons that you can't put it together. And even if you manage to put it together, it doesn't release enough energy, right? So what happens? This energy inside becomes smaller and smaller and smaller until energy is practically zero. What happens then? This gravity is the only force that's there. And so stars begin to shrink until they form what is called a white dwarf. It's just a small dead star. Alright? But if a star is super large and has a lot of mass, then it won't stop at a white dwarf. It will implode on itself and result in a supernova. Right? Supernova is a big explosion that releases all the stuff. After a supernova, you could have a white dwarf, or most interestingly, you can have a black hole. We'll get to what black holes are in the next video, but they're very interesting, so I suggest you'll stay tuned. Okay? So this is the basics of how the universe formed, what's gravity, and how eventually our sun formed, right? You can think of the star in the explanation as our sun. Right? So in our solar system, right, let's say this is our solar system, there's just a bunch of stuff, random stuff, right? And some of that stuff collapsed in the center to form our sun. And our sun started to exert a gravitational pull, so all this stuff stayed there, didn't go anywhere. And each of this stuff started to clump together on their own. And when they clumped together, everything in their orbit around the sun was taken and added to them. Right? Everything in their orbit around the sun was taken and added to them. It's like this was taken and added to them. So eventually you just had a bunch of these objects orbiting the sun without any extra material left behind, right? These objects just in their own gravitational pull, they took all the material in their path and began to orbit the sun in their own corresponding orbits. Right? And these things are what we call our planets. Earth is the third planet from the sun. Right? We have Mercury, Venus, Earth, Mars. We have an asteroid belt in the middle. Jupiter, Saturn, Uranus, Neptune, and Pluto, which is no longer a planet. So this is how the planets in our solar system formed and how our universe is going on. Just for reference, Earth was formed 4.6 billion years ago. That's 4, 6 followed by, let's say, 8 zeros. Okay? And the universe itself, based on the Big Bang Theory, was created 13.8 billion years ago. So the Earth was created 4.6. The universe itself is 13.8. So universe is like 3 times as old as the Earth, right? So that's very interesting. But this is just the basics of astrophysics. Hope you enjoyed this video. Stay tuned for more. Thank you very much.